I hope all are safe during this lockdown time. This video is regarding giving some input about optical signal processing. And you all are aware of this electrical signal processing the data electrically for transmission, before transmission and after transmission, right? For example, voltage amplification is a signal processing event, a simple signal processing event, and complicated this audio format, video compression, video format conversion is are complicated, and this signal processing is used in everyday life, right? So computer, the motherboard doing a lot of signal processing, our mobile phone doing a lot of signal processing. For example, a simple example is this video actually transmit both audio and video, right? So this audio signal is captured by the microphone in the mobile, and it is converted into electrical signal. So this microphone is actually a transducer, right? First it converts this audio signal into electrical signal, but the output of this microphone is of low amplitude. First we had to increase the voltage, right? Voltage level. So there we use the voltage amplifier, then increase the power level, then finally given to the antenna. The antenna transmitted to the destination, right? So these are the steps happening in electrical domain. So electrical signal processing is all are familiar. So why we go for this optical communications and optical signal processing? So the optical communication is familiar with all, I believe, because it is a physical medium that can transmit more bits per second. That means the capacity, the bandwidth capacity is much higher compared to other physical mediums, and the interference is very less compared to electrical domain. So before going to more about this optical signal processing, as per the IEEE definition of this signal processing, it actually gives the technology we use in everyday's life, right? Already I mentioned computer, we are using a lot of signal processing application in computer, and our mobile phone is an example, audio processing, video processing, a lot more we are doing, right? So all are enabled by the signal processing, and it's a technology that models and analyze data representation of physical events. So I was talking about our audio is a physical event, right? So IoT is we are using Internet of Things. A lot of sensors are used. Sensors are actually transducers. So it capturing the physical events like temperature, humidity, and all those things converted into this electrical domain, and then processing the signal and gives out the result, right? So it makes our digital life much easier, this signal processing, and enhances our ability to communicate and share information. This is as per our IEEE definition about signal processing, and it's empowering today's entertainment and tomorrow's technology. So let's go to the optical signal processing. The term optical signal processing can refer to a broad range of technologies or techniques that operate on optical data signals. So we have electrical data signal as well as optical data signal. So let's see what are the components or equipments which are working on this optical data. Is for example, optical amplifiers is the best example. Other examples are dispersion compensation. Dispersion means the spreading of this pulse, right? A simple way we can define dispersion means pulse spreading, right? So optical pulse shapers is another example. Wavelength converters, optical multiplexers, demultiplexers, equalizers, optical switches. That means logic circuits, optical memories. So these are the examples of optical signal processing components and equipment used for optical signal processing. So this optical signal processing, it can this process the data either in analog domain or in digital domain or both. So analog optical signal processing is there, digital optical signal processing is there, and both the hybrid version of optical signal processing is there. So while we going to this optical signal processing, we should know why we are going to this optical signal processing. Already we have a mature technology like electrical signal processing. So the main advantage of optical signal processing is high bandwidth. So In electrical, this data is processed at the speed of maximum 100 Gbps. So this electrical signal processing, the basic unit is transistor, right? There is switching speed limitation, carrier recovery time. So the maximum speed of operation is 100 Gbps, and we all know the Moore's law, right? So Moore's law means the number of transistors per chip doubles every 18 months, right? So Moore's law cannot be held for a long time because too many transistors will slow down the processing speed, and transistors have their own physical size limit, right? And in addition to that, metallic wires, so the connection wires and metallic wires, soldering wires and everything limits the speed of operation, and resistors per unit length in the chip is being increased and causing power usage and excessive heating, right? So another most important thing is that electronic equipment is strongly dependent on the data rate and protocol, and thus any system upgrade results in the addition and replacement of electronic switching speed. So whenever there is a format change or protocol change is happening, we have to upgrade the system. So that actually expecting more cost up, right? So what I am trying to say is that in optical signal processing, we need not touch or switch every individual bits as as happening in electrical signal processing. For an example, suppose the optical amplifier, that is EDF, EDFA, right? Earthband of the fiber amplifier. So it is bandwidth is entire C band, right? Commercial band. So whatever the wavelength happen, I fall into the bandwidth of this EDFA, all are amplified, and it's not going to the individual tributaries or low speed tributaries for amplification of signal. So no need to touch on individual bits, but it is happening in electrical domain. Another example is mirror based MEMS, right? MEMS is micro electromechanical devices. So mirror based MEMS can be used in this optical signal processing. So the data, actually we are transmitting data in the form of packets, right? So packet coming to the one port, it can converted into, deviated into, transmitted to other ports by this mirror based this MEMS, right? For example, another example is wavelength conversion, where the data information can be transferred from one wavelength to another wavelength. So we are using the fiber nonlinearities, that is speed up to femtosecond response time for nonlinearities. Using this wavelength conversion, the optical signal fly through this device. So we don't need to go for the bit level processing of signal that is happening in electrical domain. That is one of the advantages of electrical signal processing. So in optical domain, the information can be encoded in amplitude form. We can encode phase, we can encode, and polarization changes, expolarization, bipolarization. We can use different types of modulation format and wavelengths. So this type of this much freedom we are getting in optical signal processing. So the optical, so that gives increase the capacity of transmission. Okay. So another important thing is that you all are aware of this repeater or regenerator. Every 20 to 30 kilometer in electrical domain, we are using repeater or regenerator. That is actually what does it do is the 3R operation. So 3R means first R starting for reshape it and re-amplify it and retime it. So 3 R's are reshape, re-amplify and retime it. So that is in optical domain what it is happening in the optical communication now. Nowadays the optical communication, so the repeater stations are separated by almost 80 kilometers, 80 or more kilometers. But what is happening at receiver regenerator station or repeater station is that this optical signal is converted into electrical domain and processing, and this 3R operation is there. After 3R operation, again converted into optical domain and transmitting. Suppose we are doing this one entirely in the optical domain, not converting into electrical domain, we can save time. The latency can be removed, reduced. At the same time, the power consumption of electrical equipment and the cost of electrical equipment we can save. So that is another advantage of optical signal processing. And what are the technologies actually enhance this optical signal processing? So nonlinear optical signal processing is getting a lot of momentum nowadays. For example, four-wave mixing, self-phase modulation, some frequency generation, different frequency generation. These are the non-linear process, and there are a lot of non-linear materials are available in this for optical signal processing. So what I am trying to say is this optical signal processing is enhanced by nonlinear signal processing and optical materials. Non-linearities in optical materials, right? So this optical materials and devices had been used for optical signal processing includes highly nonlinear fiber (HNLF), semiconductor optical amplifiers, silicon waveguides, chalconated waveguides, and periodically poled in lithium neomet (PPLN) waveguides, and photonic crystals. And so the function that can be performed with these nonlinear devices, including wavelength conversion, is possible. Optical multiplexing and demultiplexing, multicasting, equalization, correlation, and the Fourier transform, that is discrete and fast Fourier transform, digital to analog conversion and analog to digital conversion, regeneration, optical logical gates, and gates, OR gate, XOR gate, etc. And all optical tunable delays and a lot more we can possible, right? So this all are increasing the spectral efficiency. Spectral efficiency means the number of transmitted bits per second per 1 hertz of bandwidth. So this another advantage of this optical signal processing is that we are using both type of multiplexing. In this one, they are this wavelength division multiplexing and polarization mode multiplexing. In order to increase the spectral efficiency in optical communication, I mean optical signal processing, the spectral efficiency is defined as number of bits transmitted per second in 1 hertz of bandwidth, right? So we are using different multiplexing techniques in electrical domain. Similarly, we are using two main important techniques in this optical domain. That is, one is wavelength division multiplexing. Different wavelength WDM technologies are used. The most important one is dense wavelength division multiplexing, and another one is this polarization mode multiplexing, right? So these two techniques can increase the spectral efficiencies, and nowadays the OFDM is also getting momentum in this optical signal processing. So some subcarriers are used, right? So these subcarriers are generated by using optical comb circuit, comb source. For OFDM, I actually mentioned they need subcarriers, right? Though these subcarriers are generated by optical frequency comb source, and these subcarriers independently modulating each comb line, that wavelength, and combining them to create optical OFDM signals. So the maximum generate OFDM channels can up to 26 terabits per second, that has been reported, and simplified 2-point FFT is performed to extract the subcarriers, right? So this optical signal processing technique may benefit not only from the high bandwidth optical devices and signal, that means huge baud rate, but also from encoding dimensions. More number of this modulation formats are there to increase the processing capacity. So far we were discussing about the advantages and some inputs about the optical signal processing, but there are some advantages of electrical signal processing as well. So electrical signal processing is a mature technology with ease of memory access, that is one of the advantages, and massive integration capabilities for accurate signal processing, that is another advantage, and electronics can provide better energy efficiency and smaller footprint. So these are the advantages of this electrical signal processing. But comparing these advantages, pluses and minus, we will get more pluses in the optical signal processing. and for transmitting huge amount of data, that is data hungry applications like this big data analysis, IoTs, this high definition video transmission, this conferencing, that is video conferencing, and this cloud computing, etc. We need this optical communication and optical signal processing. That's all for the time being. I hope I conveyed the idea of optical signal processing, the basic fundamentals of optical signal processing. Thanks for watching. Bye bye.